All right, thank you so much. Hi, everybody. Everybody feeling energetic after lunch?
Yeah.
All right, that's what I, okay, wow, okay. Well, don't get too excited, it's just philosophy, okay? So, I need to admit, I'm really happy to be giving this talk because you don't usually tend to see philosophy on the menu at these conferences. So, just thank you all so much for being here and for sticking around. So, why are we here today? I really have three goals for this talk. And the overall goal is to build awareness about what I think is a scientifically productive link between two literatures and between two conversations that I don't think are really talking to each other right now. And so the goals are to establish that link and to show you that learning analytics and philosophy have actually more to say to each other than they potentially might be saying right now. The second goal is to outline some of the recent conversations and questions that the philosophers of modeling and computer simulation have been asking that are relevant to the learning analytics community. And the third one is to suggest ways that we might actually reinforce and even potentially evolve that link. So those are the three goals. Ideally, we'll hit all of them by the end. And so let's get right to it. But before we do, there's a really important question to answer, and that's, why talk about this now? I mean, philosophy has been around for a while. Learning analytics have been around for a while too. Why talk about it now? Well, one of the reasons is that we've always been doing learning analytics. We've always constructed means to capture learning. We've always constructed tasks and assessments to evaluate and to elicit learning. And we've also always done some kind of study, be it experimental or not. The difference today is that we've increasingly digitized and datafied and even automated those functions. So this is a new variable. We're able to actually take humans potentially out of some of the decision-making loops that we use to construct these kinds of learning analytics, and we're able to scale them in a way that we haven't been able to before. So we're able to put these at scale, automate them, and use them without necessarily human involvement. Maybe worth reevaluating how we're doing it in the first place. The second reason is, as we achieve this kind of technological scale and automation, people start to take notice. And critical analyses, and when I say critical, I don't mean necessarily negative, although they have negative aspects to them. When I mean critical, I mean challenging assumptions of the work that we do. Critical analyses that challenge these assumptions have been on the rise. And not just from educational science, they also come from computer science, they come from social science, and they really get us to question, is what we're doing, is it for the benefit of society? Is it for the benefit of our science? And is it for the benefit of the governance that we are going to put forward? So if you combine those two trends, we're achieving bigger scale with better digitization. There's also increasing scrutiny from outside the field. What you also get is increased reflection from inside the field itself. And so you can take a look at some of the article titles up here. But generally speaking, when you get articles in a field that begin to ask if the very phenomenon you're observing exists, you know something's probably going on, right? And this is kind of the cool moment that's happening in the learning sciences right now. We are beginning to question, and question broadly. Do we have the right theories? Do we have the right phenomenon? This thing called big data, is this really bringing something new to the table, or is it not? How do we envision what learning analytics look like going into the future? So there seems to be something happening right now. And into that mix of what's happening right now, I want to bring philosophy to the table. And why look to philosophy? Well, one of the reasons is, if you've read any of William Sandoval's work, he came up with this idea of an embodied conjecture, which is super powerful. Basically what he did is he and his colleagues constructed a piece of software called Explanation Constructor, and they ran studies with it, as one does. And what he was able to do is actually deconstruct the software and the studies they ran into the specific philosophical conjectures and assumptions related to learning. What are the embodiments of learning theory and learning philosophy through the technology? what are the conjectures around learning, how learning happens, who it happens for, why and when it happens, that you can see in the technology and the studies they run. So they actually found a framework for how to bring that to the forefront and make it extremely explicit. Knight, Shibani, and Buckingham-Shum then extended that work and actually took it directly into the digital learning analytics space, where what they did then, and this is the big addition to their work, if you can see these gears, those gears indicate the places in this mapping where learning analytics augment the process. So you're actually able to see where some form of automation or some form of digital technology takes center stage and where it doesn't. So we not only have a way to see that technology embodies our philosophies, we also have a way to analytically dissect the role of the technology or the role of automation in that. And then, as if that weren't enough, we also have reflections from learning science broadly and learning analytics specifically that, whether you like to or not, we are already all engaged in philosophy one way or another. Knight, Buckingham-Shum, and Littleton created this triangular framework where they actually break down the fundamental building blocks of learning analytics: pedagogy, assessment, epistemology. Bowler, in a fantastic reflection on multiple years of her work, also creates a triangular framework where she points out one of the things that we all need to do as learning scientists, and even more so as learning analytics designers, is ask critical questions of our knowledge. What is knowledge? What is worth knowing? And how do we know that we know it? And then how do we make sure that our learners know it? I'm not asking anyone to do anything different as a result of philosophy. We're already doing it. We're just not necessarily 100% aware of which aspects of philosophy we're engaging with and how. But there is a tradition of us doing it. And these are not the only publications to point it out. They're just the only ones I found that have a beautiful triangular framework. I thought that would do good. All right. So, okay, philosophy. I don't know if anyone's picked up a philosophical book recently. If you dust off your old Aristotle, that's not what I'm talking about. Okay, we're not talking Plato, we're not talking Aristotle, we're talking a little bit more recent, a little bit more modern. Specifically, look to the philosophy of science. And what you see is that over the last 10 years, there have been fantastic books coming out that really highlight the conversations around the complexity of phenomena and how to model them, around what are models, how scientists build them, and why. And even what non-epistemic values, political, social, personal, come into play when designing these kinds of systems. After all, somebody needs to make the decision which piece of data to collect and why. And that might not always come down to a scientific curiosity. There might be politics at play. Does raw data exist? And if so, how do we know that they do exist or that they do not? These are the kinds of questions that, as somebody who has experience building learning analytics and even standing up big data infrastructures right here at Stanford, these are the kinds of questions I started wondering about myself. And I didn't really know who to turn to when I started to ask them. And so I started to turn to philosophers. Turns out they've been talking about this for quite a while. The cool thing about this, as you can see in the subheader, is, like all of us academics, these books aren't always intended for practitioners of the art. They're mainly intended for philosophers, right, for your peers. What's different now is that some of these books are explicitly being written for policymakers, for practitioners, so that the philosophy becomes more understandable to us and more actionable by us. So I want to hone in on two specific conversations that I think are relevant to all of us who are interested in design and learning analytics. The first one is, what is a model? And this is kind of a standard view of what a model might be in the philosophy of science. You have a target system, predator-prey. You might model it. There might be three kinds of models: a concrete or a physical model, a mathematical model, and a computational model. And then you have model descriptions. So you need to find a way to actually communicate your model to others. And you might employ equations, graphs, videos, pictures, what have you. These models are then used for a variety of reasons. Sometimes they might be used to actually advance theory and theoretical understanding. Sometimes they might be used to advance computational methods, because in order to make a model work computationally, algorithmically, you might need to do serious innovation in that area, not just in the theoretical part of it. Now, as you're looking at this, two things might stand out. One, the words seem extremely specific, right? Models realize model descriptions. Model descriptions specify models. This is because this is one of the things that philosophers are extremely good at. One of the things that philosophers do is they scrutinize the words we use and that scientists use. And they help make sense of them. They help disentangle them. And one of the great things that I've actually learned is it's kind of fun to be able to read a lot of these conversations about the words we use in our everyday language and publications and see somebody else kind of interpret and reinterpret them and make them clearer, refine them so that we can then bring them back in. So that's the first thing you might notice. The second thing you might notice is, wolves and bunnies, that's nice, but that's not what we really deal with. How do you translate this model of model making when what you're analyzing might be unobservable to you? What happens when you don't have that physical reference point of being able to watch a wolf or a rabbit or an ecology? Also, what happens when we don't even really have consensus on what it is that the phenomenon itself, the nature of it might be? I mean, are you really looking at learning or are you looking at behavior? If you're looking at neurons firing and you have a good model for that, does that mean you also have a good model for learning? These are the kinds of questions we are increasingly going to be facing, especially as our analytics become more multimodal and as we begin to onboard, especially neuroscience, into this field. There is a philosophy of psychology, there is a philosophy of neuroscience, and yet they also share this rather realist view of things, that there tends to be a real physical observable. In my experience of design, learning, and analytics, that's not really the kind of process I go through. I don't think about a physical brain. I think about a human being, and usually an immaterial mind. The second conversation I want to highlight is something that we all go through. What's the actual process of making a model? And so Winsberg, who wrote a fantastic book on the use of computer simulation and computational modeling recently, he puts forward this idea that, ideally, the way you build a model, especially a computational one, is you find a theory, you build a model around it, then you make sure the model validates the theory you picked, then you somehow find a numerical scheme to instantiate that model. You make sure that that is a good treatment of the model, and so on it goes until you get a nice result from the solver that you run, right from the very computer program. And then you somehow verify the principles. Sounds good, except that's not how it really works. Anyone who's been through this process, it looks a little bit different. And Winsberg shows us two really important aspects of how the modeling art actually differs from this ideal view. One is that the numbers that result from the solver, that's not the point of a simulation, that's not the point of a model. The point of a simulation or the point of a model is some qualitative understanding of a phenomenon. It's not about the numbers, it's about the understanding. The other thing is that to sanction our models, we don't just look to theory. We look to theory, physical intuition, what might fit into the model, and also computational easing, what actually makes it run. So again, thinking to what we do, what's the equivalent of physical intuition for us? Is it psychological intuition? Is it educational intuition? And does this match what it is that we do? I would actually say that it does a pretty good job, but it misses a few important things, namely that I think learning scientists and learning analytics designers spend a lot of time figuring out how to operationalize or invent a measure that goes into the numerical scheme or into the model in the first place. That tends to be a lot of the intellectual work here. But it's a good start, right? And this is a good approximation of what at least other scientists have done and how we can import it into our own work. So now that we've set the ground here, I just want to say this is not a new phenomenon. John Dewey, writing in 1929, almost 100 years ago now, he pointed this out as well, that there was a philosophy of education, but he was talking about philosophy also more broadly, that could be a source of science, of education. And it just wasn't being seen that way at the time. And I am not sure that we're doing much of a better job right now of doing that as fields. Individuals might be doing a good job of it, but as fields, we're not really talking to each other, using each other as sources of our own science. And I think it's particularly surprising because going off of where we began in this talk, we all do philosophy. We embody it through the technology we design. We use it. We make philosophical, epistemological stances in the analytics we design, and also looking to some of the recent work done in the field of epistemic cognition, the learning environments we design also have the potential to change the epistemological beliefs of our learners. So we embody it, we use it, and we change it, whether we want to or not, or whether we were even aware of it or not. Although it would be great if we were more aware of it, which is really where I want to end. The call to action here, and the metaphor I like to use, is the following. From a lot of educational psychology and psychology in general, we have this notion that metacognition is an incredibly powerful force, that it's not just practice that evolves your practice. It's reflection and thinking about your practice that allows you to actually evolve and figure out the limits and how to break through them. Well, we're right now not using the metacognitive field that's supposed to be helping us with this, and it's called philosophy. And so this is supposed to be a teaser, this is supposed to be an appetizer, but please, go talk to a philosopher somewhere. Find a philosopher near you, they're there. Or pick up one of the books I showed in this presentation, or come talk to me or something, but converse with the literature, because we have an incredible community of people and we're not engaging with them, and they're here to help, and we have something to contribute. We're not looking at primarily physical systems, and we are looking at something that has epistemological payload, and it's called learning. And there isn't a philosophy of learning. There's a philosophy of education, and it primarily deals with ethics or policy, not with the issues that we are engaging with. So the choice is on us. We don't have to perpetuate this kind of a paradigm of working together. We can actually we can choose to do something different. We can actually create a productive science that's not just practice, practice, practice. It's practice plus philosophy. So, thank you all so much.
Touched on it a little bit. You talked about, that there's a philosophy of education, but then you also said something about ethics.
Mm-hmm.
Can you just talk about, I somehow think that it's more important to talk about the ethics of education. Not more important, but just as important.
Yeah, so let's talk about philosophy of ethics for a minute. So there is a deep tradition of talking about the philosophy and the ethics of education. But again, it usually tends to come from the policy or from the economic side of things. These kinds of ethics that are now coming to the forefront, if you look at the recent discussions around ethics in learning, analytics, and big data, they're actually not coming from educational ethics. They're coming from the ethics of computing and the ethics of, well, actually epistemological considerations of big data. There's been now a slew of articles around, are big data actually, new phenomena, or are they not? So ethics are important, and they definitely do come into play. I think, one of the books that I highlighted earlier in the presentation, Ben Williamson, Big Data and Education, the whole through line of that book is, if we are increasingly going to digitize and datafy education, and if we are increasingly therefore also going to bring humans out of the loop, who's going to govern the algorithms? And who's going to govern the databases? And those are the ethical conversations that I think are really coming to the forefront. But again, those don't tend to come from an educational perspective or from a learning perspective. Those tend to come from a social or computing perspective. And those are conversations about us without us. And I think that's one of the reasons why I started going deep into this work, because I want us to have a seat at that table. Because if we're not going to decide it, somebody else will. Yeah.
Mm-hmm.
And creativity, right?
Mm-hmm.
How do you think that, all that stuff, curiosity, creativity, questioning, association, all these things link up to this?
Yeah, so this is a great question, right? How does curiosity and just forming things that have not been formed in the past, those forming new linkages, how does that come into play? Well, so the first thing is not everybody would necessarily agree that that's the core of learning, right? And that's one of the things that we're really bumping up against here, that learning means so many things to so many different people. That just figuring out if that is how we're defining learning, what are the ethical and philosophical implications of it, and analytic ones too, is interesting, right? How do you fundamentally build an algorithm that uses past or historical data to predict how you're going to do something that is not in the historical record? That's so, one question there is, analytically, how do we wrap our heads around it? There's definitely something that philosophers and computing scientists and learning scientists are trying to figure out. The second thing there that I really see in your question is, you're really talking about epistemic virtues. And this is, if you're really interested in this, look up this term, epistemic virtues. These are basically, so philosophers, and especially epistemologists, have been trying to figure out for a long time, not only what is knowledge, but why do we want it? Why is knowing valuable? And specifically, what is it that distinguishes like an epistemologically responsible learner from an epistemologically irresponsible learner? And can you be an irresponsible learner and still be a good knower? Right? This is a whole field. And there's actually been a few educational psychology and learning scientists here at Stanford who investigate those questions from a psychological standpoint. One of the best instantiations of this that I've seen is researching to say intellectual humility, and that's really the psychological instantiation of those philosophical concepts. And also, again, these are choices that we get to make, right? And the reality is, even though it's fantastic to be talking about, there are all these sociocultural, philosophical theories of how learning might occur, putting them into an algorithm is then a different animal. And so you can look up, there are papers by James Greeno, for example, from the 90s and 80s, where he actually sketches out what sociocultural computational models of learning might look like. We have not really picked that work up. And there are reasons for that are beyond the scope of this talk. But if we believe that that's important to us as a community, we might want to actually dedicate effort to it at conferences, in research groups, and just generally.
Thank you, Peter. That's great.
Thank you.